Hey everyone, and welcome. Did you know that every single number has its own secret code? Yep, kind of like a special DNA that makes it totally unique. Today, you and I are going to be number detectives. We're going to learn how to crack these codes together. Sounds fun, right? Let's get started. All right, first up, let's look at a real life mystery. Have you ever heard of these insects? They're called cicadas. Now, here's the weird part. Some of them hide underground for, get this, 13 years, and others wait 17 years. Why those numbers? 13, 17? It seems so random, but guess what? It's not. It's actually a super clever survival plan. And the key to unlocking this mystery? It's all math. Stick with me, and by the end of this, you'll know exactly what their secret is. I promise. Okay, so to solve this cicada puzzle, we need a special tool in our detective kit. We need to understand a very special kind of number. I like to call them building block numbers. You know, just like how you use bricks to build a house, well, all other numbers are built from these special ones. Let's go check them out. Let's start with an easy one, the number 6. So, what numbers can we multiply together to get 6? Well, there's the obvious one. 1 times 6 equals 6. Cool. Are there any others? Yeah, how about 2 times 3? That also makes 6. So the numbers 1, 2, 3, and 6, they're all connected to 6. In math, we have a special name for them. We call them factors. Okay, now what about the number 5? Let's think. What can we multiply to get 5? Well, there's 1 times 5, and is there anything else? Nope, that's it. Just 1 and 5. See the difference here? The number 6 had 4 factors, right? But 5 only has 2. It's different, it's special. And that special quality brings us to a huge idea in math. A number like 5 that only has 2 factors, just 1 in itself, has a very important name. We call it a prime number. Go ahead, say it with me. Prime number. So numbers like 2, 3, 5, 7, even 11, they're all prime. These are the building block numbers we were talking about. So really, we're sorting numbers into two main teams. On one team, you've got the prime numbers, like 7. They only have 2 factors, 1 and, well, 7. Then you've got the other team. These are numbers like 6, with more than 2 factors, and we call those composite numbers. So basically, if a number isn't prime, it's got to be composite. It's one or the other. Simple as that. Okay, you ready for a quick challenge? Let's take the number 9. What do you think? Is it on team prime or team composite? Let's check it out together. So we know 1 times 9 works. That gives us 2 factors, 1 and 9. But can we think of anything else? How about 3 times 3? Yes. So 3 is a factor too. Let's list them. 1, 3, and 9. That's 3 factors. And since that's more than 2, what does that mean? It's a composite number. Awesome job. Fantastic. So now we know all about prime numbers. That's the first major tool for our detective work. Now we just need one more thing. It's a really cool shortcut that's going to help us write math way, way faster. So take a look at this. 2 times 2 times 2. Writing that isn't too bad. But what if you had to write 2 multiplied by itself 10 times or 100 times? Oh man, your hand would get so tired. That would take forever. Luckily, some very smart people came up with a shortcut. And here it is. This is the shortcut. Instead of writing out 2 times 2 times 2, we can just write this. See that? It's a big 2 with a little 3 up at the top. The big number, the 2, we call that the base. That's the number you're multiplying. And the small number, the 3, is the exponent. The exponent just tells you how many times to multiply the base by itself. So this means multiply 2 3 times. We read this as 2 to the power of 3. So much easier, right? All right, detectives, this is it. We've got our tools, we know about prime numbers, and we know about powers. Now it's time to put them together. We are finally ready to uncover the secret code, the DNA of any number. And this awesome process has a name: prime factorization. Our first case file, the number 12. Our mission is to break this number down into its smallest parts. We're going to keep breaking it down until we're left with nothing but prime numbers. Okay, let's go through this nice and slow step by step. We start with 12. Now the rule is to always try dividing by the smallest prime number first. What's that? That's right, it's 2. So can 12 be divided by 2? Yes, it can. 12 divided by 2 gives us 6. Awesome. Now we're looking at the number 6. Let's stick with 2. Can we divide 6 by 2? Yep, 6 divided by 2 is 3. Perfect. Okay, now we have 3. Can we divide 3 by 2? No, that won't give us a whole number. So what do? We just try the next prime number up the list. After 2 comes 3. And wait a minute, 3 is a prime number. So once we hit a prime number, our job is done. We stop.
So what did we find? What are the prime building blocks of 12? Well, we found a 2, another 2, and a 3. Let's just double check our work. Good detectives always do that. What's 2 times 2? That's 4. And what's 4 times 3? It's 12! It worked! We did it! We successfully broke 12 down into its prime parts.
Okay, one final touch to make our code look super professional. Remember that shortcut we learned? The powers? We've got 2 times 2 here, so we can write that as 2 to the power of 2. And so the secret DNA code for the number 12 is 2 to the power of 2 times 3. That's it. That is the prime factorization of 12. And what's so cool is that it's like a fingerprint. No other number in the universe has this exact same code. You're getting really good at this. Let's try one more together just to make sure we've got it down. Our next target is the number 18. Ready to crack its code? Let's go.
All right, here we go with 18. First step, always start with the smallest prime, which is 2. Can 18 be divided by 2? Sure can. That gives us 9. Great. Now we're at 9. Can we divide 9 by 2? Nope, not this time. So we just move on to the next prime number on our list, which is 3. Can 9 be divided by 3? Yes, it gives us 3. And hey, look at that. We landed on 3, which is a prime number, so we know it's time to stop.
So let's collect our clues. What are the prime building blocks for 18? We found 1, 2, and then a 3, and another 3. Now let's use our cool shortcut. We have 2 3s, so we can write that as 3 to the power of 2. And there it is. The final secret code for 18 is 2 times 3 to the power of 2. See how that works? You're a natural at this. That's the one-of-a-kind DNA for 18. Okay, this is awesome. You now know how to find the secret DNA of a number. That is a seriously cool math skill to have. But you might be wondering, so what? Why does this even matter? And that is a great question. To answer it, let's go all the way back to the beginning of our mystery. Let's talk about those cicadas again. So remember those cicadas? The ones that pop up every 13 or 17 years? Well, what kind of numbers are 13 and 17? Think about it. They're prime numbers. Now, the animals that like to eat cicadas, they're predators, they usually have life cycles of, say, 2 years, or maybe 4 or 6 years. Those are all composite numbers. If a cicada came out every 6 years, a predator that comes out every 2 years would get to eat them all the time. But since the cicadas use a prime number like 13, their cycle hardly ever lines up with their predators. It's nature's way of using math to stay safe. How amazing is that? So let's do a quick recap of everything we uncovered today. First, we figured out that all composite numbers are just made of prime numbers, our building blocks. Second, we learned that every number has its own unique secret code. It's prime factorization. It's like a mathematical fingerprint. And finally, we saw that this isn't just a math trick. This code actually helps us understand how the world works, from tiny numbers all the way up to solving mysteries in nature. Pretty cool, huh? So today, you learned a new superpower. You can find the secret DNA inside any number. That is amazing. But, this is just the beginning. So here's something to think about for next time. What if you have this secret codes for 2 different numbers? How could you use those codes to see how they're connected or what they have in common? That's our next big puzzle. Thanks so much for being an awesome number detective with me today.